Hello and welcome. Today we're going to begin talking about astronomy. And I'm starting with this first slide to remind you that we're going to be spending the next 2 weeks on Unit 3. And Unit 3 is broken into these three parts, A, B, and C. Today we're going to be working on Unit 3A. And this video is the beginning of 3A, which is divided into 9 short videos. The system of video naming is similar to what you saw in Unit 2 and 1. The video names here begin with ASTR for astronomy. They're followed by 3A for Unit 3A, and then .1, .2, .3, all the way up to .9. And they should be watched in order. Here we are beginning the first video in Unit 3A, and here's a reminder of the learning outcomes. You might want to pause the video and just read these to remind yourself of the outcomes of this unit. A little reminder about my recommendations for taking notes in this class. Pause the video whenever necessary to write down information on the screen. I'm not going to have a lot of information on the screen, but I will have important things like vocabulary terms and key concepts. In my face-to-face classes, these would usually be things I might write on the board, and I always tell my students, if I write it on the board, you should be writing it down too. You should definitely not write down everything I say. Please don't. But if I happen to say something that will help you remember the material, please go ahead and add that to your notes. I also encourage you to write down questions that come up as I discuss the material, and then if you can't find answers later on, you can ask me about those. Okay, let's get started. So what is astronomy? Well, astronomy is the study of the objects in space, such as planets, moons, stars, galaxies, even the gas and dust that's out there in between all those larger objects. And we're going to study that. Astronomy is also the study of Earth's place in that space among all those objects. So here are those definitions that I just mentioned. So if you want to pause and write those down, that would be a good thing to do now. We're going to begin our explorations into astronomy by thinking about our solar system. You will learn that many things in astronomy have names: planets, moons, galaxies. However, our solar system is just called our solar system, and it consists of many different kinds of objects. But for this lesson, we're only going to look at 3 different objects: the sun, which is a star, the planets, and their moons. Now, moons are called satellites or natural satellites to distinguish them from artificial satellites, which are those instruments that humans put in orbit around Earth to measure various parameters of the Earth. I like to begin thinking about our solar system by going back thousands of years to the ancient Greeks. I like to start here because much of what they observed are the kinds of things that you and I can observe. Most of us believe, because we were told at a very early age, that the Earth goes around the sun. However, if you were just going to go based on what you see, you wouldn't really conclude that. I go outside every day, and the sun seems to move across the sky throughout the day. In the morning, it rises in the east. In the evening, it sets in the west. I don't feel like I'm moving. It seems to me like the sun is moving. And the same with the moon. The moon's in the sky in different places. Sometimes it's not there. It seems to me that the moon is moving. And so this is what the ancient Greeks also saw. They believed that the moon and the sun moved around the Earth. They also decided that the Earth did not move at all and was located at the center of everything. This is called the Geocentric Model, that the Earth is in the center of the solar system. I like to break down words and think about different parts of the word. So here we have the word geo, which you're going to hear a lot in this class, and that means Earth. And then we have the word centric, which means the center. And so this is the model that puts the Earth in the center of the solar system. Now, keep in mind that we know today that this is not correct. But we're going to start here, and then we're going to see how ancient astronomers figured out that it was wrong. So the Greeks were also very keen observers of the nighttime sky. After all, what were they going to do after the sun went down, right? Not a lot of options. So they studied the night sky, and they noticed that most of the stars did not move relative to each other. And so here's an example. This is the Big Dipper. And the Big Dipper might be a constellation that you are familiar with. It's got 7 main stars in it, shown here. And these stars are always at the same distance relative to each other. They're always at the same angle relative to each other. They don't change year after year, decade after decade. These stars are always in the same place relative to each other. And so that's what the ancient Greeks noticed, that most stars are in the same position relative to each other. So I'm going to add a bunch more stars here, and I'd like you to do the same on a piece of paper. Just add a bunch of stars to a piece of paper, and you don't have to include the Big Dipper if you don't want, and they can just be random like this. So even though most of the stars did not move relative to each other, these careful observers did notice that there were 5 objects that seemed to move in the night sky relative to all the other stars. And they call these the 5 wanderers. So I'm going to add these, and I'd like you to add these too to your drawing. And I'm just going to make them circles to make them a little different than the stars. And so night after night, the position of these, they don't look very good as circles, sorry about that. But night after night, these objects seem to wander or move through the fixed stars. These 5 wandering stars, as it turned out, were actually planets. And in fact, the Greek word for wandering star is planetai, and that is the origin of the word planet. So you might want to pause and see if you can figure out what 5 planets can we see from Earth without a telescope. Because remember, there was no telescope thousands of years ago. I'm going to put them up here in order from closest to the sun to farthest. So see if you can figure them out before I do that. Here we go. Mercury, Venus, Mars, Jupiter, and Saturn. Now, of course, Earth is between Venus and Mars, but they didn't think Earth was a planet. They didn't think Earth would be so ordinary, so Earth is not included here, of course. Okay, so another sketch I would like you to do with me. We're going to draw what the ancient Greeks thought the solar system looked like. So this, you should put a title, is the geocentric model of the solar system. So the Earth, they put in the center, and not only did they think that the Earth was the center of the solar system, they thought the Earth was the center of the universe. So you can label it center of the universe. Now they knew that the moon sometimes passed in front of the sun when they saw solar eclipses. So they felt that the moon was closer to the Earth than the sun. And they also saw that the moon passed in front of the planets, the wanderers. So they put the moon next in their model. So they got that right. They also noticed that Mercury and Venus sometimes passed in front of the sun. So they put those planets next, Mercury and Venus. Next, they put the sun. Following that, they put the next 3 planets, Mars, Jupiter, and Saturn. And then finally, around everything, they put a huge sphere of stars, which they felt were all surrounding the entire solar system at some incredible distance. So that was their model of the solar system. And that was fine. Everybody was happy with that. However, those careful nighttime observers found problems with this model. And one of those problems is going to be the topic of our next video, called retrograde motion. So, see you then.